Well, we got a touch more moisture and instability, and things are more vertical today. You can see that tropical moisture streaming north, and in some parts of Texas, last night, thunderstorms in northwest Texas. And this clip here comes from one of our viewers, David Moore, out in the Knox City area. That's about between Abilene and Childress. And that shows some of the hail coming down. Looks like dime-sized to maybe a few quarter-sized hailstones. And that's associated with a left split. You can see it here at the top of this animation. The storm was moving northeast and had anticyclonic rotation. So there it is, finally getting some storms in Texas and getting into a late spring type pattern. So for today, I think it would be good to start out with the visible satellite picture. We've got storms going up across East Texas and also in Northwest Texas from about Graham, Possum Kingdom Lake up to about Quanah. So where are these coming from? Let's go back to this morning. You can see we got a thunderstorm complex coming out of southern Oklahoma, and we got a little bit of outflow coming across the Red River. And looks like that evolves from an outflow boundary into a gravity wave. See how that pushes south, and we can see it reflected in the low cloud field? However, there's not really a wind shift with that. It's starting to propagate outwards, kind of as a ripple in the pond. And as you know, ripples in the pond, they don't push leaves and debris and stuff like that along with them. They tend to make them rise and then fall. And that's kind of what's happening here. Southerly flow coming across that gravity wave, just kind of rising as the gravity wave passes, and then sinking on the other side. And the gravity wave continues propagating south. However, the vertical push is helping some of the parcels to break the cap. And that's why we're getting these favored axes of storms set up, as you see here. Now, as a forecaster, one of the first things you should be asking yourself is, are the mesoscale models picking up on those gravity waves and the initiation locations? I've gone back to the 16Z, the late morning model, and yeah, it's breaking up precip in that Possum Kingdom Graham area and also in East Texas. In fact, that matches pretty well with the satellite. I mean, look at that. It even got that little triangular shape there. That's pretty good. So can we see that gravity wave on the wind plots? Well, it does appear as an outflow boundary apparently in the region northwest of Fort Worth, but we're not seeing that out in East Texas. Unfortunately, we only have a very limited set of charts to really see this, and I think ideally we should have the low-level omega field, but I don't know of any site that provides that. I mean, you could probably do that with wind grids. That's a very good program, but let's see. Yeah, it's not showing that on the supercell composite, probably because of maybe the convective inhibition term zeroing out everything. Significant tornado parameter, yeah, same deal there. Bulk shear. No help on the bulk shear. So I don't know. You know, I would love to see these gravity waves in the model output, but we're not really given those tools to look at that stuff. However, these gravity waves do move at a fairly constant rate, maybe slowing down a bit, so you can actually use extrapolation to kind of figure out where they're going to be later in the afternoon. And then line that up with areas where you think the model is initiating convection. So yeah, this is probably more due to the outflow boundary, and this is more of a gravity wave feature. Now, one thing that's kind of interesting is if you look at the trends on these cells, they're just kind of pulsing and dying, little turkey towers out there. So they're actually not coming together. The stuff in East Texas is definitely coming together because it's impinging right there on the moisture coming up from the Gulf. So I would expect these to be a little bit more long-lived. So where can we expect convection? Well, this convective field right here looks a little bit more persistent. That's going to be out around Vernon, Texas, along Interstate 287. So maybe some potential there, but we're going to have to look at the surface field and maybe some of the skew-t's. Okay, let's go into our surface analysis. It's gotten a little bit complicated due to outflow out on the Central Plains there. But we're going to start out with the western U.S., have a new polar system moving into Nevada, Utah, and Wyoming there. Looks like the center of the low is somewhere in eastern Nevada probably. But you can see the north winds once again bringing in a new shot of cold air. Out on the Great Plains, we've got our funnel system there in Kansas, and we can see the northeasterly flow in Dodge City and Guymon. We've got a pretty active system there in northern and eastern Arkansas. Looks like an outflow boundary, pretty well defined there in eastern Oklahoma, and then some older boundaries down in northwest Texas like we saw in the opening clip. And in the middle of that, the dry line. Looks like that's past Wichita, lurking around Blackwell, Oklahoma, down to Clinton, and extending all the way down to Vernon, Abilene, and down into the Pecos River Valley. And out in the southeastern U.S., a couple of sort of tropical thunderstorm lines, one in Alabama and the other in the eastern or the western Carolinas. Big difference there. This is the SPC experimental meso analysis, and the green and blue shades, those are going to be your moisture. And you can see that some much better moisture is indicated by the yellow shades here in East Texas. So moisture pretty much everywhere east of the dry line all the way up towards the polar low there in Kansas. But the field is deformed a bit by outflow. And you can see these red lines, see how they curve like that? That's indicating the outflow pool. And in the very center of the outflow pool, 64 degrees. Probably a little hard to read that, but it's there. And we can give a rough indication of the leading edge of that active outflow about like that. Now this is going to be an approximation because this is from the rapid refresh model. It's not going to be accurate as your surface analysis. So you can use this as a starting guide to where to look further at the data. And then a little bit of indication here of, looks like model generated convection there, kind of deforming the field a little bit. And then down to the south we can see the sea breeze. See that got a temperature discontinuity there. Leading edge of that temperature discontinuity, we kind of treat that like a cold front and put it on the warm side of the gradient. So on the north side, 86 to 88 degrees, kind of in this area, and then on the south side, 80 to 82 degrees. I like these mesoscale models. They're very good at picking out those sea breeze circulations. They're not going to be accurate, but the important thing is it is reflected in the data. Now, of course, you can also go in and look at your theta. That's what we use in mountainous areas for temperature gradients, and it works the same way out on the plains. See right there? Yeah, that's going to be your leading edge of your outflow. And, you know, I would use theta all the time, certainly. It's going to be equivalent to temperature if the terrain is horizontal. Out in mountainous terrain, your temperature is going to reflect mostly your hills and valleys, but theta should be somewhat more consistent, reflecting the air masses. Let's look at some thermodynamic quantities. Surface-based CAPE. Wow, very high surface-based CAPE there. These values are running close to 5,000. That's pretty impressive. It's a little reminiscent of the Jarrell day back in '98. Mixed layers should bring that down a little bit, but we're still well up in the 4,000 range. So we have a very unstable environment across Texas, and less so out in Arkansas, where we're running about 2,000 to 2,500. So now it's time to look at some soundings. So I think it's going to be very hard to beat the model soundings. I'm going to place that out away from the storms. This should sample the inflow into anything that develops there near Possum Kingdom Lake, west of Fort Worth. And we can see the steep lapse rates, and the moisture has definitely improved from 70s trailing into upper 60s up at about 5,000 feet. And you can see that the most unstable parcel is well to the right of the temperature line. And that gives us a very extensive area of Cape. However, the air mass is uncapped. That's very important. That means if storms do get going, there's going to be a lot of them, and there's going to be a lot of cell competition. And that'll tend to reduce the possibility for rotating storms a bit. Also, the wind flow is kind of weak. You can look down here in this inset here. Storm relative inflow is not too bad, actually, running about 20 knots, so it's going to be a little bit like yesterday. You can see it's indicating storms moving to the southeast at 10. Inflow vector is kind of running like that, so you're getting about 20 to 25 knots of inflow from the southeast. However, most of your other quantities, your 4 to 6 kilometer shear is marginal, and your storm relative anvil ventilation is kind of on the weak side, so that's going to put you in the HP range. Let's take a look at a couple other soundings. Let's look at the Hillsborough area. Very good parcels there. Dew points near the 70s. Very steep lapse rates, and that's given us some very impressive capes. Yeah, we've got a little bit of sea earth or 1 kilometer shear there. Not a whole lot, but it's enough to sweep out a little bit of SRH. And the profiles are definitely putting us in the HP-ish territory. Model forecast going for, let's see, convective complex across the counties northwest and southwest of Fort Worth. Also East Texas getting some stuff going down around Crockett and Lufkin. And you can see what I'm, this looks to be that outflow boundary gravity wave thing. And I think what's happening is it's still propagating to the southwest a little bit and kind of giving us that little axis of development. And it looks like maybe the dry line is initiating also. However, to get a good organized rotating storm, it's going to come down to getting easterly flow in the low levels, because that easterly flow is what's going to stretch your photographs around and give you better SRH there. So we can look at the dew point field with the wind overlay. We can see that the SRH is not going to be so great down to the south, but it should be enhanced northwest of Fort Worth in that area there. In fact, we can probably grab that wind plot, see how it's coming out of the southeast. That should give us kind of like the best case SRH, and you can see that there. A little bit of backing, a little bit of 0 through 2 kilometer shear, kind of stretching that out, a little bit of capping, and that gives us an algorithmic tornado probability. So I don't see anything here screaming tornado potential, but this is great instability, and I would expect maybe the possibility of a few isolated tornadoes out there. After all, it is May. SPC going with an enhanced risk up in the Dallas-Fort Worth area westward. You can see that there is a little bit of tornado potential. They've brought it up to 5% up there in that corridor that we talked about northwest of Fort Worth mostly. Definitely a little bit of wind potential. Yeah, that D-Cape is still way up there, 1600. And definitely some hail potential. No mesoscale discussions in effect for Texas. There's an area up there in Nebraska, but we're not going to be able to look at all that. And a severe thunderstorm watch in effect there for Texas. There's the day 2 for tomorrow. Maybe somewhat of a repeat of yesterday, and also some expanded potential in the high plains. And there's the day 3 potential. In Europe, that cold front has moved across the North Sea into Benelux and Germany. So there's the cold front there, very strong cold front for that part of the world. And it's driven this area of showers eastward across Germany, and it's at this time approaching Berlin, Copenhagen, and Sweden. And a strong area of cold air advection in its wake. And there's a recent satellite picture of that system. This is probably from about midday over there, and I don't see anything that looks like it's strong convection. Probably a lot of this is like forced showers and that kind of thing. But it is sweeping eastward, and there's all the cold air advection cumulus in its wake. And if you go even further west, you get into the cold core stuff there in Ireland. And there's the main low, well offshore. You can see there in England how the flow comes onshore, very cold conditions, and then it picks up surface heating. Because it is May, we're only 1 month away from maximum insolation, maximum surface heating. So that really gives a kick to this air mass, and we end up with very steep lapse rates and very unstable conditions. So we get these vertically developed cumulus fields, probably sheared over. But that's kind of a showery, blustery pattern, and it usually subsides at night. So some very interesting weather for our friends in Europe. And that's about all I got for today. I want to go ahead and get this uploaded so we don't have any more delays. Now keep in mind that this is going to be a 3-day break, unless you're a Patreon supporter, and I'll put up that link there. That will get you access to an extra 1 or 2 bonus videos each week. It'll likely be 1 video this weekend since we don't have a whole lot going on. But if we get into a busy severe weather period, you will get more videos to look at. Otherwise, if you're not a Patreon supporter, we will see you on Tuesday. Take care and have a great weekend.